do you know about deep learning? So I'm going to share with all of you how much I know about deep learning. So a lot of people is started talking about deep learning in the recent years, the past 2-3 years. But why now? Is as in it happens. This thing is already there for quite some time, and why deep learning only gets the hype now? So deep learning on the news for last year and this year, we can see that we have AlphaGo, a company that Google bought with 400 million, that won the Go, which is a board game, against the Grandmaster, Lee Sedol. So this caught people's attention that AI can actually win Grandmasters. So this is, have you ever used Facebook and upload the image and then they suggest you to tag your friends? So all this thing is actually run by deep learning. So they know who you are, they know who is your friend, and they will suggest you to tag your friends or not. And whatever ads that we see or whatever things that is in timeline, Facebook will do a profiling of us, and actually they will show you what is relevant to you. So they target advertisement to you and stuff like that. So these are the deep learning. So Uber, late last year, Uber has a self-driving car that is already on the road, and which is now still already on the road and still testing. Then we have this. This is actually a news like 2-3 days ago. So Andrew Ng, the founder of Coursera, the professor in Stanford, and also the chief data scientist for Baidu, has created Xiaodu that is going to challenge world record holder on face recognition and sound recognition in Superbrain China. So it's a TV series that showcases people with special talent, and they are the world record holders. So this robot is, for the first time, they are competing against a robot instead of human and human. So this is very interesting, and the series will start this Friday, so onwards, so we can see. So what is deep learning? Deep learning essentially is actually a neural network, a very deep one with a lot of hidden layers. So this is how a deep neural network looks like. One problem, there's a problem with this for so many years. Since 1990, they already have people that is actually doing deep neural networks, but nobody uses it because of these two reasons. So before 2016, there are these two main reasons. One is that it takes too long to train. Another one is inaccurate. So why is it too long to train? So imagine this a very simple case. Every time we calculate the weightage, we will have to do a back propagation. If you want to back propagate this point, we will have to calculate the gradients for these two. But what if we want for this point? There are so many calculations that is involved. So imagine a deep neural network like just now, it will take very long to actually train the model. And it's inaccurate. Imagine the value for the first layer is this, is 1/12, it's still okay. But the next layer will be even smaller, and the more layer it goes, it will be very small, and the gradient will be very inaccurate. So that's the reason why deep neural network wasn't being used, and most of shallow neural network is outperform a deep neural network. So what happens in year 2006 is that Geoffrey Hinton, also known as the father of deep learning, he has created restricted Boltzmann machine, a concept where this is how it works. So it has two layers, visible layer, the input layers, and also the hidden layer. So a visible and a hidden layer. Pretty simple. So the restriction is, the restricted in this RBM is that every nodes don't connect to itself. So in a way that it's only depending on the input layers. And how it trains is that they will do a forward and a backward. So in forward phase, the input, they will go through against the bias to get the weightage and the bias. And then they will do a backward to recreate the input. And then they will do this KL divergence to compare the recreated input against the actual input. Then they try to minimize the errors. So this is how RBM works. So with the concept of RBM, here comes deep belief network. It's a deep neural network, but the structure is the same. This is how it looks like. But the different thing is that this is the pre-training phase where you have the input and the first layer. So how is it different is that they approach it in such a way that this is 1 RBM. They will train as accurate as possible for the first layer before going to the next layer. Then they will train the next layer as in another RBM, as accurate as possible, and so on and so forth until the last layer. So at this stage, none of the labels is being labeled, none of the characteristics is being labeled. So it's a pure pattern finding, pattern recognition. They will then put in labels to actually know how accurate they are or which category belongs to what. So you get a very highly abstracted features at the last stage. So this is what deep belief network in year 2006 until now. But at 2006, nobody seems to use deep learning as in the hype. So it waits until year 2012. In this event, ImageNet Large Scale Visual Recognition Challenge. Every year, this challenge will have a lot of researchers or machine learning experts or image recognition experts coming together to really compete with each other to know how well they can categorize the image. So how this competition runs is that they will be given 10 million images. It can be a cat, a dog, and so on and so forth. So everyone will try to write their algorithm to be the best and to categorize as accurate as possible. So Geoffrey Hinton and his team joined this competition in year 2012, and this is the result. So University of Toronto, where Geoffrey Hinton is in, has a very introduced deep learning in this competition. So he used deep learning and he get only 15% error rate. While every other people that uses machine learning that writes their own feature selections or try to optimize the features, and they can only get 26% error rate. So the 10% error rate difference has caught a lot of people's eyes. So if you look into this, it's very interesting because you can see how Geoffrey Hinton actually proposed the usage of GPU in deep learning and how they can make RBM along with GPU to actually make the more efficient and reduce the error rate greatly. So what are the other use cases except image recognition? So in sound, we can see that voice recognition, voice search. So in terms of sound, we use them a lot. Siri, Google Now, and all that, we are actually using this. And in terms of flaw detection, engine sound, so they run the test for engines and all that. We are actually using this to know whether there is an anomaly in terms of the engine sound. So it can be aviation industry or the automotive industry. Images, we use it a lot. Google search, Google image search, facial recognition for Facebook, and machine vision and photo clustering and so on. So video is actually a series of image. So they are also being used. Time series is mostly focusing on recurrent neural network, where they see whether there's a trend or predicting the next values. And text, like word to vec and all that, is widely used in deep learning. So all this I actually get from deep learning for Java. So what they suggest that can use deep learning. So other than this, what are the other cases of deep learning that I think is good? So this. So being able to train and get a highly abstracted feature, we can then give very limited labels to tell the machine that apple should look red, or chicken should look like this, or a car usually is red color when it's this model. So we can change a black and white image to a colored image. So this uses a convolutional neural network and recurrent neural network to actually construct the thing. So CNN, which is convolutional neural network, will learn the image and know what is in the image. Then RNN will construct the string, as in the text that we are actually seeing, that match directly to this. So other than that, we also have, this is created by Google. So Deep Dream, or also known as Inceptionism. So this is the original image. then they add on with the highly trained features on a dog or animal. Then we get to see this a little bit weird, but it's sort of a creative image. So, and that is, yeah, with the dog asking on it. So as a conclusion, I would say that deep learning can run with limited labeled data. Not all data requires you to be labeled, and it's very suitable for complex tasks. Machine learning will always do better for a very simple task that doesn't. If you can construct the feature and you know how to construct the feature, then it's better to use machine learning. Or else deep learning can be a very good choice, and it works very well given a huge number of data. And be sure that the data is of quality. Same goes to machine learning. So last month I went to Wrangle. So Adam Gibson, the creator of deep learning for Java, says this, that deep learning is still very young and many use cases is not being tried. So I only share a few possibilities of what you can do. So that's it. Thank you very much. That is a deep dream of my future.
Wow. Okay. Right. Thank you very much, Mr. Tan. And now, are there any questions from members of the audience? Would you like, would you like to share about what you are using deep learning for?
Okay.
Before you continue, is mind that we're recording this and this will be uploaded somewhere. So don't share anything that would be in breach of whatever stuff you have signed.
Okay. So my research is actually using deep learning to construct high-level features because it's related to telecommunicational data. So there are a lot of data, unstructured and structured. So I use deep learning to find whether there are ways to actually construct the new features that is highly abstracted and can improve the machine learning outcomes. So it's in the way of using the last layer and then to apply back with any other machine learning algorithms.
You think transfer learning?
It's not transfer learning because I'm actually testing it on not image, not video, but it's more of a semi-time series with categorical data. So it's more of experimental. So it's really up to how the team construct and tune it in such a way.
Any other questions? Are you guys not interested to maybe pick his brain on how deep learning can be used in the context of your own research problem? John, any comment? Anything you want to clarify or comment on? John does a lot of deep learning.
Depends on what he wants to disclose. I can ask you, are you using the deep learning nets for unstructured data? So if you're using that, then how do you use DBN for unstructured data? Categorical is not a problem, but unstructured data.
It's a mixture of all of them, and I'm actually still at the stage where trying out things. So it's really not very deep into it yet because I'm still in the early stage of my research.
When you're working on time series, I think you can try the RNN type of the family of methods, including the long short-term memory. Yeah. So those proven to be quite good. But you may have to do some embedding before putting it into the LSTM.
One question, so you are working with unstructured data, right? So I was just wondering, before you go into your feed it into your neural nets, the deep one, do you just chuck it in or do you do some pre-processing?
Initially, I tried chucking in, but not so good. So I think I'm back to the pre-processing phase where I have to really look into the data and see how I should change it in such a way that it can be trained via deep learning.
Okay, maybe one last question, anyone? No? Okay, thank you very much, Mr. Tan, for kicking us off. All right, and we you guys have any other things to ask him, we can take it offline. Okay, thank you very much.